Welcome back to the Digital Foundry in New Kensington. I'm the executive director here, and we are on part 3 of our 6-part series, Smart Manufacturing for Business Success. And today, we will be exploring the topic of machine controls with our automation and controls engineer, Josh Stearman. So join us for today's presentation and come back next week to learn more about supervisory controls.
What's going on, everyone? I'm back with another Tech Talk Tuesday to talk about PLC machine control. For those of you who missed the first couple episodes in this series, I'm Josh Stearman, the Senior Automation and Control Engineer here at the Digital Foundry. And without further ado, let's get to it. So, we already covered level 0 of the automation pyramid, and now we are taking a step up to level 1, which is all about machine control and PLCs. Machine control does as it says and controls the inputs and outputs of a machine based on logic written by an engineer. Modern controllers will also communicate to other systems up and down the various levels of the automation pyramid. While there are other options for machine control such as PCs and microcontrollers, programmable logic controllers or PLCs are most commonly used in industrial settings. This is because they are ruggedized to withstand harsh environments, use common programming languages made for industrial processes, and have very fast cycle times for fast processes. They also have expandable modules for inputs and outputs, remember level 0, as well as connectivity to other machines, networks, or specialized field devices. Since they were originally developed to replace legacy relays-based logic, the programming is similar in style to relays-based electrical drawings. In the images above, you will see some of the more common PLCs from 2 major players, being Rockwell and Siemens. Now we are going to talk a little bit about the PLC components in the cabinet. 3 key components to a PLC system include 1. The CPU, which stores and executes the program. 2. The I/O modules, which connect to the I/O devices based on the project scope. And 3. The backplane, which is the high-speed bus of the CPU and I/O modules used to communicate. As a bonus, we also show the power supply, which obviously provides power to the unit. Typically, you will see a PLC in an electrical enclosure. Some reasons for this include that it will protect the user from electrical hazards in the cabinet itself, protect the PLC and equipment from environmental hazards such as dust and water, provides electrical noise shielding for sensitive devices, especially the PLC and other communication-related devices, provides lockout-tagout means for maintenance, which is very important for safety. It is typically laid out in an ease of use for troubleshooting, with space to test electrical connections, and finally it allows for heat dissipation and may have fans or vents. Let's talk about ladder logic. Although seemingly outdated, its simplicity and ease of troubleshooting has kept it relevant, and it is often used for the main functions of a PLC program. Since it is a graphical-based language, it is usually easier to follow when troubleshooting. You'll notice in the example above, the power rail is on the left, and if the logic instructions evaluate to true, they pass power to the output instructions on the right. The most common input instructions are examine if on and examine if off, and the most common output instructions are output energize, output latch, and output unlatch. It is important to keep in mind that when input instructions are in parallel, either can be true to pass power, but when instructions are in series, both have to be true or on to pass power. Staying on the topic of programming, there are 2 programming environments we will focus on: Studio 5000 and TIA Portal. They each have the same general programming using ladder logic, but have different styles. Rockwell has subroutines, Siemens has blocks, where and how you create tags differs, how you configure the PLC and set IP addresses are different, the list goes on. There are a multitude of ladder instructions besides the basic bit logic of coils and contacts. Some others include timers and counters, math operations, compare operations, and alarms and interrupts. Additional devices may be added to the project that have pre-developed software modules for easy integration with PLC programming. PLCs are designed to ease and troubleshooting. There are local indicators, LEDs, that will tell you if an input or output is on or off. The connections typically have removable terminal blocks as well for ease of replacing components. A very helpful feature of PLC programming environments is the ability to watch your program as it executes. Green, in this example, indicates a true instruction or passing power while the program is running. As an example, if you're looking at your PLC and you expect a valve to be on, if the PLC output light is on but your valve is not, your program seems to be correct, but wiring may be the issue. If the PLC output light is not on, you should check your program as it is probably not correct. Note, readability by other engineers should be the primary aim of your program style. Avoid super clever code and comment very well. The last point I want to hit on in this episode is the importance of machine-to-machine communications. M2M is crucial to smart manufacturing in that it describes how information is sent to and from different levels of the ISA 95 automation pyramid. Typically, you will see a standard Ethernet Cat6 cable for secure connections, but nowadays wireless connections are becoming more common. There are multiple protocols or languages to choose from, such as Ethernet IP, often seen with Rockwell, Profinet, seen on Siemens, OPC UA, which is a server client model, MQTT, and Modbus. Now we'll go to the Digital Learning and Demonstration Lab here at the Digital Foundry to look at our machine bottling line simulator, Mabel. Alright, hey everybody, it's me, Josh again, down here at our manufacturing bottling line, aka Mabel. So the reason I'm here right now is because first you'll notice there's a PLC, sort of the topic of this whole video, right? It's doing the main control over our simulation of this bottling line. We also have an HMI and an IPC running some SCADA up here as well. I want you to notice too, on this screen, I'm actually running TIA Portal, monitoring the Ladder Logic live as we're running it. And if you guys can see that okay, you'll notice as I hit this button, there's a rung on there that changes between green and not green, indicating that there's power passing through. So I'll hit that a couple more times. Hopefully you guys can see that all right. And now I'll go ahead and start the application. First resetting it. Now we'll go ahead and start it. I'll move into another page to show you some data that is changing as this machine is running, and basically give you a little bit of the quick overview of a PLC. So we have obviously the PLC here. You'll notice some LEDs, indicator lights triggering according to different inputs and outputs like we talked about in our last video. Then you'll also notice the I/O modules that are communicating with the field devices over here. So that's kind of the gist of it. Hope you guys got it. See you in the next one.
So while today was just a very brief glimpse into how we define smart manufacturing and why you should care because it can have real value to your business, we want to close with letting you know that we can be of help at the Digital Foundry. At the Digital Foundry, our mission is to focus on delivering access to digital technologies through education and training, through awareness events, and through technical assistance or de-risking with manufacturers in our region. So we can help you in taking those steps to become smarter in your operations, to implement smart manufacturing, to make better decisions. And some of the specific services that we can provide to help you get there include starting with assessing your current state, coming in and helping you to understand what are the biggest challenges and where should you start small to continue to access success and wins. We can help you with mapping your strategy and your plan through strategic road mapping processes that have been proven with other participants in industry. And we can help you with doing prototyping and de-risking of technology in our shop, where you can see how it works, understand it, understand the business value before you go out and make investments in your shop. We also offer unique workforce training to help you to upskill your staff at levels from entry level on the plant floor all the way up to your engineering staff. And we can provide coaching for your team to make sure that you're setting yourself up for success. We're here to be of service to the workforce of the future and the current, and we also are here to be an asset to local manufacturers. So take advantage of what we have to offer and some of the support that we can give you in taking this journey. Thank you for being part of our Smart Manufacturing series, and we look forward to talking to you again. Please connect with us through our website and social media.